Hi everyone, welcome back. We continue on this list and today we are going to learn about statePost function. Actually this function is just giving us the information of the current Kalman state. What I mean is if we switch to the code part and maybe rerun the simulation, in here there is a white circle which we are trying to track, which we are trying to apply Kalman filter. So this is the real point, and also in the Kalman world side there should be a point which Kalman should consider during the calculation. So that point in this simulation is the green circle, and this is the current state of the Kalman, and we are assigning this at the beginning 0 to 0. In here you see statePost function is started as 0 to 0, and the next 2 point is just meaning the velocity in the x and the y direction. If we go to the statePost explanation in the code part, in here it says the first one is gonna be considered the point, the state of the position of the x-axis and the y-axis, and the next things is gonna be just the steps. For example, in here the initialize as 0 to 0, and that's why at the beginning if we run simulation also, if I continue, that's why it start as 0 and it's not directly putting to the correct position of the green with the real. It's not matching faster because we started far the state of the Kalman, we initialized far to the real object. Okay, but of course for each loop in here we are calculating after the correction, Kalman is correcting the current state, so it's always updating our statePost value. For example, if we just copy in here, we started as 0 0, and if we write it to the console, okay, and now we are gonna see it's always updating in each loop. It started for example, of course it started 0 to 0, we just wrote to the console the next position, so now it's updated to 300 to 200, but the current situation is, if we make it bigger, the current real is about 300 240 kind of, and now it's still wrong. We see the previous one, and now it's getting closer, and at the end it's correcting very well. But what if we give at the beginning the correct position? For example, we are starting the white circle, which is the real position of our object which we are trying to apply Kalman. This is about, if we put this rectangle little above, and we start the Kalman state with the same point in here, and if we give the same step size, which is 5 to 5, which we initialize here. So by the way, we just continue these steps. Now we already learned here. Now we continue with the statePost, and we are going to continue accordingly. At the end we are going to understand this simulation, and we are going to understand Kalman. Anyway, just now we are expecting it's going to start in the correct state, correct position with the real object, so we don't need to be worried at the beginning. It's gonna, yeah, you see it's totally matching with the real white object, and it's following accordingly. The next, this for initializing state is important at the beginning if you do not want to wait much for Kalman to match with the real one. So giving the statePost correctly at the beginning is important, but otherwise at the end it's gonna correct its statePost accordingly again. Also during the loop, in some cases if you want to change the state, you can apply the same thing again in here. Maybe in some situations you want to update the step size, or you want to give some offset to the x and the y axis of the position, so you can apply anything in here, so it's gonna update itself accordingly again. Also in here for the future one, which is the red is going forward, right? Again in here we are using the statePost. We are just cloning it to the future state now, and after that we are with an iteration we are just trying to understand the next one, so we use statePost again to predict the 10 iterated future steps, so we are using again statePost here. So in this video basically I just want to talk about statePost, and in the next video we are continuing accordingly. Thanks for watching, see you.